The tech study channel. In the previous class, I have explained diagram for university schema. In this class I will explain diagram of employed schema. So in this class I will explain diagram of employee schema and entities of this diagram, attributes of this diagram, relationship types or mapping cardinalities in this diagram, and each mapping cardinality in relational database means explaining with an table examples how they are related to each other. And so before going directly to the diagram, I will explain what is data model and what is entity relationship data model. Means ER diagram is easy to build through these topics. Okay. So first, data model. Data model is a visual map or blueprint that describes how data is organized, stored and related to other data. In a database system, okay. A data model is a collection of conceptual tools for describing data relationships, data semantics, consistency constraints. These four concepts I have explained in the previous classes. If you want that, then watch that videos. Okay. And then if it describes the design of database at each level of the data abstraction. We have a levels in data abstraction, like logical level. Here, conceptual level, physical level. Conceptual level is also called logical level, and physical level, and view level or external level, we can say. So the data stored in these levels are designed through data models. And it acts as a bridge between a real world business and the actual database. The two main data models are a entity relationship model, which is ERM, and the relational model. Okay. So we will see what is an entity relational model. It is based on the notion of real world entities and the relationship among them, and how they interact, means how they interact with each other, how the entities are interacting each other, and what are their relationship. Through the entity relational model, we will know that. And while formulating real world scenarios into the database model, the ER model creates entity set, relationship set, general attributes and constraints. So by using these entities, relationship sets and general attributes and constraints, we develop the ER data model diagram, means design. Okay. It is used for conceptual design of a database. It is based on entities and their attributes, relationships among entities. So these are entities and this is the relationship. These entities are represented by rectangle, and relationship represented by rhombus or diamond, and attributes represented by oval. And then entity, a thing in the real world that we want to store information about, and attribute, entity having property called attributes. Domain, every attribute is defined by its set of values called domain. Means in a column, uh, consider one table name is entity, okay, and attributes means column names are attributes, and domains means the set of values defined to a particular column. Means like example integer and varchar. Integer means which stores the numbers, and varchar means which stores the text. So domain is like a data type of a variable, okay. In this entity relational model, domain is a data type for column name. And relationship, the logical association among entities is called relationships. Mapping cardinalities define the mapping cardinalities is also called relationship types, defines the number of association between two entities. There are 4 types of mapping cardinalities are there: one to one, one to many to one, many to many. I have explained this for entity relational model in the previous classes. And naming and conventions, rules, these are the rules that ensures clarity and consistency when designing a database, which is through entity relational model, okay, by which both technical team and business stakeholders can be read easily. And for entity, the rules are using singular nouns, example student, not students, and starting with capital letter or entirely uppercase. This entity should be starting with the capital letter or entirely uppercase. It should be singular nouns, and every entity must be unique name. Means these two entities can't have same name, okay. All entities in a diagram should have a unique name. And then avoid technical jargons, like technical jargon words are utilize, terminate, and other many are there. So simple words are use, stop, like that. You have to avoid technical jargons and you have to use simple words, okay. For attributes, using singular nouns, as I have said for entities, this is also same. And means these attributes, for these attributes the rules are as followed. These using camel case or start with capital letter. So camel case means except first word, all remaining words starts with the capital letter, so that is called camel case. How means for example, camel case, here we have started with the capital letter, second word is started with capital letter, so it should be start with the capital letter, or it should have camel case, okay. And entity name is used as a prefix to clarify the attribute, like customer address comma employee address. Entity name means a table name. Table name is used as a prefix means the word which is added to another word, added in front of another word, like here in the example customer and employee are table names. Address and address are column names. So to clarify the attribute, we are using these prefixes, okay. Means the address belongs to which table or which person. If we want to know, then we will use these prefixes. or to easily identify the columns from different tables. Okay, and then primary key. Primary key must be underlined. Okay, and then for relationship, use a present tense verb like works for enrolls, uh, which are not the examples are worked, enrolled, like that. We don't use that. Okay, names readable from left to right or top to bottom. Okay, in the diagram, entity relational model diagram. Okay, so symbols are meaning, and symbols and meaning, entities, all entities except weak entity, uh, all entities are represented by single rectangle. Okay, and weak entity is represented by double rectangle. Then relationship is represented by rhombus or diamond, identifying relationship double rectangle, double rhombus or diamond. Attribute oval, and key attribute underline plus oval, multi-valued attribute double oval, composite attribute. One attribute is subdivided into multiple attributes, and derived attribute dotted lines, total participation of E2 in R, which is represented by double line, and cardinality ratio 1:n for E1:E2 in R. Means how the mapping cardinalities are represented in the diagram. It is showing like that, one to many or one to one or many to many, like that, many to one, like that. It is a 1 to many, so 1 to n. If it is 1 to 1, then 1 to 1. If it is many to 1, then n to 1. And if it is many to many, then m to n, like that. And structural constraints, minimum, maximum, or on participation of E in R. So here minimum indicates if E is an entity, if minimum number of values or specific entities in this entity are participating in this relation, then that indicates the minimum. And maximum indicates the if maximum number of entities, specific entities in this particular entity are participating in the relationship, then it is indicated by maximum. The number we write here. Okay, and then we will see the diagram of diagram of a employee. So here is there. It is the ER diagram of an employee. So from employee, it is not clear. That's why I am explaining this. Employee assigned to project. Okay. Nothing is there here. Okay. Only a single line is there. Okay. From assigned to project. Okay. And then between two entities we can have multiple relationships in the relational database. So here we have multiple relationships, like employee manages department and employee works in department. And entities are employee, department, dependent, assignment. Means it's an associative entity. Okay, assigned to or assignment we can say. Okay, to give a proper name to a table we have used the word assignment. Okay, its actual word is assigned to, is an associative entity. And certification, vehicle, and project, these are the entities represented by rectangle. And attributes represented by an oval, like certificate ID, title, model, license, project name, project number, like that. All these ovals are representing attributes. And then relationship represented by rhombus or diamond. Here we have has, dependent, works in, manages, assigned to, drives, holds, are the relationship types, relationships. Okay, and then types of entities. What are the types of entities are present in the ER diagram? Here in the ER diagram, all types of entities are present, like a strong entity, weak entity, associative entity, intangible and tangible entities. Okay. So first, a strong entity, an entity that exists independently of other, because it has a primary key which uniquely identifies each row in the table. So it does not require any other table relationship. Okay. So examples are of strong entity are employee, because it has employee ID, department, it has a department number as a primary key, and certification, it has certificate ID, and vehicle, it has license plate primary key, project, it has a project number primary key. And weak entity, an entity that so here dependent is not a strong entity because it is a weak entity. Okay, it contains a partial key, not primary key. And weak entity, an entity that can't be uniquely identified by its own attributes alone, means it does not have primary attribute and depends on a strong entity. Okay, here the example is means the weak entity's partial key is dependent on employees employees table employee ID, because partial key according to the definition of partial key, it combines with the primary key of the strong entity and uniquely identifies each row in the table of weak entity. And here dependent which is a loan, which depends on loan, which depends on employee. Okay, then tangible entities, a physical object, means tangible and intangible entities, we can consider it as a real world things and an imaginary things. Okay, so is a physical object, like examples employee, vehicle, and dependent, which may be son, daughter, or spouse of an employee. Okay, So here dependent means a dependent DBMS refers to an attribute whose value relies on another attribute values known as the dependent. So here in the diagram, tangible entities are employee, vehicle and dependent, which are physically exist in the world. And intangible entities, a conceptual objects that has no physical form, like department, certification, project, assignment, okay, or assigned to. So why they are tangible and intangible entities means employee have entity have a physical presence in the real world, like example humans. Vehicle, we can see, touch and move it, like example car. And dependent represents physical person, okay. And intangible means certification represents a qualification, it's not a physical existence, okay. Project represents a conceptual task. An assignment, an associative entity, represents a relationship or event working on project rather than a physical object. And department, an administrative unit, while it may have an office, the department itself is a legal and structural concept. If one asks that what's your department, then we will see we will say that CSC or CSD or 3 like that. So it's a logical and structural concept, not a physical thing, okay. That's why they are tangible and intangible entities. And then we have associative entity. So a relationship that is treated as an entity to link multiple entities together, okay. Here example is assigned to or assignment, okay. Connects employee and project, storing specific data like state date, start date and hours worked. So here associative entity means it also holds the relationship, means assigned, like in this example assigned to, and it has its own attributes, like in this case hours worked and start date, okay. So it is represented by a rhombus inside a rectangle, okay. It is used for many to many relationship to avoid the severe redundancies, okay. So what's the difference between relationship and an associative entity means relationship means the association between two entities, and uh, associative entity means it holds the relationship, means the association, it holds the association, and also it has its own attributes, like in this case start date and hours worked, okay. And then we have types of attributes. Here partial key in the dependent table is dependent name, okay. And then key attribute, a unique identifier for an entity, means which uniquely identifies each row in the table. An example is employee ID, department number, certificate ID, license plate, and project number. So these are primary keys which are indicated by oval and underline. Here also oval and underline, and here also oval and underline, and vehicle also. Vehicle has a license plate as a primary key, and project has project number as a primary key. So then simple attributes, an atomic value that can't be subdivided. Example, gender, department name, location, relationship attribute, and gender of department dependent, project name, model, title, start date, hours worked. These are the attributes which are not subdivided in this ER diagram. And composite attributes, an attribute that can be divided into smaller subparts, like name which contains a full name and last name. And single valued attributes holds only one value for a specific entity. Like example, date of birth of the employee, start date and hours worked of the associative entity, gender of the dependent, and title, and all key attributes are single valued attributes. Okay, it's an statement. Okay, all key attributes are single valued attributes because a key attribute uniquely identifies each row in the table. So means for example, an employee and employee name and employee IDs are there. So employee IDs are primary keys because it will not have null values and redundant data, means repeated data. So each employee has a unique primary key value. So that means a unique key identifies each row in the table uniquely. So all key attributes are single valued attributes, means each primary key holds only one value for a specific entity, like in this case employee. Okay, and dependent name, relationship, gender, project name, first name, last name, department name, location, model, title, all these are single valued attributes in this particular ER diagram. Okay, for different ER diagrams, the single valued and all key all the attributes values are changes. Okay, multi-valued attribute can hold multiple row values for a single entity. And here an employee having multiple phone numbers is a multi-valued entity which is represented by double oval. And then derived attributes, an attribute whose value is calculated from other attributes. Example, age derived from date of birth for an employee. And then mapping cardinalities, number of association between two entities is called mapping cardinalities. And here employee table, department table, project table, dependent table, vehicle table, certification table are there. So here is the representation of mapping cardinalities, each mapping cardinality in the relational database with the example tables. Okay, so here first we have a one-to-one relationship between employee and department. Here we have one-to-one relationship between employee and the department, which is manages. Employee manages department. How the relationship is established, we will see now. Okay, each employee manages each department. So what is the definition of one-to-one relationship in the relational data model is each row in the first table relates to exactly one row in the second table, and each row in the second table relates to exactly one row in the first table. This is the definition. Here we are writing according to that each employee manages each department. So each employee manages each department. Okay, first we are creating statement for from 1 to 1, from left to right. Okay, that is each employee manages each department. And example is considering employee table, looking at 101 and 102 employee IDs. 101 and 102 employee IDs. Each of them manages D01 and D02 departments. Okay, means unique departments. If one employee 101, here also we have 101, this employee manages D01 and D02, that will not be accepted. Okay, only one should manage only one department and other should manage another department, and likewise several employees and several departments will be there. Okay, and then each department is managed by exactly one employee. We are making a statement from right to left, that is each department is managed by exactly one employee. So example is at D01 and D02, each of them are managed by employee 101 and 102, unique employee 101 and 102. Means this D01, if we write twice here, and this D01 manages managed by employees 101 and 102, means one to many relationship will be generated, so that will not be accepted. Only each department D01 and D02 are managed by exactly unique employees, those are 101 and 102. So to generate this output table, that is employee table, we have an important rule. In any one-to-one relationship, the primary key of one entity is usually placed as a origin key to the any other entity. The primary key of any one entity is usually placed as a origin key to the any other entity. So entity means tables. Okay, means here we have tables. Here we have tables, employee table and department table. So the statement meaning is the primary key of employee ID can be placed in the department table as a origin key. Means employee ID is placed as a origin key in the department table, or we can also put department tables, department number primary key in the employee table as a origin key. If we put so either ways are correct only. Okay, and if we put employee tables primary key, that is employee ID, in the department table, then department table will become output table. Okay, and if we put department tables department number primary key in the employee table as a origin key, then employee table becomes output table. Here output table is employee table. In this we have inserted department number primary key as a origin key of the department table. So, and this origin key should not be repeated. It is unique. The values of this origin key should be unique, because it is a one-to-one relationship. Only one department is managed by only one employee, and each employee manages each department. So that's why we should not use redundant values in the one-to-one relationship in case of origin keys. Here the another possible output table is department table. In this, employee ID primary key of the employee table is placed as a origin key. Here also the same, we didn't repeated the origin key values. Means we didn't write 101 101 twice, or 102 102 twice. Okay, only one ID one time. Okay, and then many to one relationship between employee and department. Many to one relationship definition in the relational database is each row in the first table relates to exactly one row in the second table, and each row in the second table relates to multiple tables in the first table. So first statement is many employees works in exactly one department. In say if we didn't remember the definition of the many to one, then we can write the statement by using this only many to one topic. Many to one title. Okay, so from many employees works in exactly one department. So example is 101 and 102 employees works in exactly one department D01. 101 and 101 employees are working in D01 employees. So here many to one relationship is established, and the statement is also established. And then creating a statement from right to left, that is one to many. Each department can contain many employees. Here in the example, D01 contains many employees 101 and 102. So that's why one to many relationship is established. And statement also. Output table is employee table. To get this employee output table, we have an important rule, that is primary key of the one side table must be placed as a for each key inside the many side table. So this rule is for both one to many and many to one relationships or mapping coordinalities. Okay, it is same for both mapping coordinalities. So here, how to consider whether a table is one side or many side. So according to mapping coordinality type, many to one, in this case many to one is there. Sometimes it will be one to many. Okay, generating a statement like many employees works in exactly one department. The title is many to one, and we are generating statement as many employees works in exactly one department, means many should come first and one should come later. In this statement also following the same rule, many comes first and one comes second. So this statement is according to the mapping coordinality. So we have generated it. So by observing underlined words we can decide it. So in this statement, employee beside word is many and department beside word is one. So employee table is many side and one department side is one side. So we place the primary key of department table, that is department number, in the employee table as a origin key. Okay, because department table is a one side and employee table is a many side. Okay, here we got the employee table, that is employee table. Output table is employee table. Okay, here we have placed it, okay, as a origin key. So in this origin key value can be redundant or repeated. Origin key value can be repeated. Okay, and then many to many relationship between employee and project. Employee is there, here many to many relationship between project, employee and project. Many to many relationship definition in the relational database is multiple tables of first table multiple rows of first table is related to multiple rows of second table, and many to many relationship definition in the relational database is each row in the first table related to multiple rows in the second table, and each row in the second table related to multiple rows in the first table. So according to that, each employee is assigned to multiple projects. So we are generating statement from left to right, that is many to many. Each row is related to multiple rows in the second table. This is a This is satisfying the first statement of the definition. Looking 101 assigned to P10 and P20 projects. Your output table is assignment table. So why we have using output table, a separate table, that is assignment table, means like in the one-to-one relationship we have used any one of main table, that is employee table. The relationship is in between employee and department. We have used any one table as a output table, okay, according to the important rule. And in the many to one also we have used any one table, okay, only one table, okay, not any, only one table from these two tables, that is employee table according to the employee rule, important rule in the many to one relationship. So in the many to many relationship we are using a separate table, not from these two tables, employees or project. We are using a associative table for generating relationship between those two employees and project tables. So why we are using this means here we have a associative entity between employee and project, means it holds the relationship as well as the start date and hours worked attributes, means its own attributes, means which type of relationship it holds, means the employee and project relationship it will hold. Why we are not using main tables to establish relationships means is because of severe data redundancy. How it happens, severe data redundancy means in the employee table and here is the project table. So if I put project primary key as a origin key in the employee table, then it's an many to many relationship. So each project number related to multiple employees and each employee is related to multiple projects. That means P10 here we have to return twice and it is assigned to, means linked to 101 and 102, and one zero one we have to write twice here, and which can be related to multiple projects, that is P10 and P20. P10 and P20. So and 101 can also contain P30, P40, like other projects also, means employee can be assigned to multiple projects, and projects is associated with many employees. Each project is associated with many employees. So here, for these redundant values, means we are inserting for region keys as a repeated values. So for these repeated values, these all data should be repeated. Full first name, last name, date of birth, gender, age should be repeated for each these redundant values. For example, 101 is repeated twice. So, and for multiple projects like P10 and P20, P30, like that. So full name, last name, date of birth, gender also should be repeated 3 times. So due to this severe data redundancy, we will avoid this direct directly establishing a relationship, many to many relationship between two tables. So I have set an example for a project tables, project number, placing it in a employee table, and if we employee tables, employee ID is placed in the project table as a origin key, then also same will happen, like severe redundancy will happen because of repeated data. Okay. So if we place employee ID as a origin key in this table, then each project number, means P10, can have multiple employees. Each project is assigned to multiple employees, like 101 and 101, 101, 102, 103, like this. Means we have to write P10 twice, thrice, or multiple times according to how many persons it is assigned to, means how many employees it is assigned to. And each employee is assigned to multiple projects. Means if 101 employees there is assigned to P10 and P20 and P30 also. So this 101 value should be repeated 3 times here, row 1, row 2 and row 3. And so in this case each employee is assigned to multiple projects. So for these for region key repeated values, the project name should be repeated. Okay. The project name should be repeated. So here severe data redundancy will come. So in the first example that I have said, that is project number as a origin key, we are placing in the employee table. So here we can repeat the project number column values, like P10, P20, P20, like that. And we can generate a relationship like in the second table, each row is assigned to multiple employee IDs, that is employee E01 and E02. Okay. For these redundant values, these data should be repeated. Okay. And Also, we can't generate a employee ID values twice because it is a primary key. Primary key definition is it should not contain redundant value and null values. So these employee IDs we can't write twice in it two particular rows like 101 and 101. So we can't generate a relationship that is the rows in the first table are assigned to multiple projects in the second table. We can't generate that relationship, which is in the many to many definition. So the first problem is severe data redundancy, and the second problem is we can't generate first statement of the many to many definition. In the project table also same. Severe data redundancy due to for region key values like employee table is placed as a origin key in the project table, then these origin key values can be repeated, means each employee ID has a assigned to multiple projects, and for that project name value should be repeated. And we can't repeat these primary key values twice, means we can't write P10 and P10, and we can't establish any relationship that each project contains multiple employees, means each row in the first table, means in this case we are considering project table as a first table. Each row in the first table relates to multiple rows in the second table. We can't generate that relationship. That's why we are not establishing a relationship directly in the two main tables. So we are using a associative table, so which holds the relationship and also its own attributes. How it holds the relationship means it brings the primary keys of both the main tables, these employee table and project table, primary keys, that is employee table, employee ID and project number, as a origin keys in this, and here it establishes a relationship. So bringing primary keys of both tables, employee and project, as a origin key in associative table to establish a many to many relationship. Here one employee is assigned to multiple tables, and which means each row in the first table is assigned to multiple rows in the second table, and P20 project is assigned to multiple employees, that is 101 and 102, means each row in the second table is assigned to multiple rows in the first table. And then we are storing start date and hours worked. for that particular employee that is doing this project P10. And then one-to-one relationship between employee and vehicle. You already know the definition, that is each row in the first table is related to each exactly one row in the second table, and each row in the second table is related to exactly one row in the first table. So that is each employee drives exactly one vehicle. Here we have employee and vehicle relationship, that is drives one to one. So we are making statement from left to right, that is one to one. Each employee drives exactly one vehicle. Looking at 101 and 102, each employee drives exactly unique vehicles, that is KA and MH, license plate numbers vehicle. And the second statement is from right to left, that is one to one, that is each vehicle driven by exactly one employee. Looking at vehicles KA and MH driven by exactly unique one employee, that is 101 and 102 respectively. Here the important rule is you already know, the primary key of any one entity is usually placed as a origin key to the any other entity. Here the entities are employee and vehicle table. So we can place employees tables primary employee ID primary key as a origin key in the vehicle table, and we got the output table, or we can establish the relationship, that is one to one, or we can place vehicle table's license plate primary key as a origin key in the employee table. Okay, and we got the output table as employee table, and we established the relationship one to one. That is either employee table or vehicle table. In this employee table, we have placed license plate as a origin key of the vehicle table, and in this vehicle table, we have placed employee ID as a origin key of the employee table. And one to many relationship between employee and certification. Here employee and certification is there. The relationship is holds one to many. So one to many definition in the relational data model is each row in the first table relates to multiple tables in the second table. Each row in the first table relates to multiple rows in the second table, and each row in the second table relates to exactly one row in the first table. So we are establishing a statement from left to right, that is one to many. Each employee holds many certificates. So looking at 101, it holds C01 and C02 certificates. Means each employee holds many certificates, and generating a statement from right to left, that is many to one, that each certificates belongs to exactly one employee. Example is looking at one C01 and C02 certificates belongs to exactly unique employees 101. Okay. Here the many to one relationship is established. Many certificates means each certificate belongs to exactly one employee. Okay, many to one. This is the regarding statement generated. Output table is generated from important tool, that is the primary key of one side table must be placed as a origin key inside the many side table. So according to mapping cardinalities, we have to generate the statement, that is mapping cardinality is one to many. So the statement we should generate is each employee holds many certificates. This is the statement which is according to the title one to many. So employees beside the each and word, and certificate is beside the many word. So employee table is one side and certificate table is many side. Here is the employee table and certificate table. So we are placing employee ID primary key in the certification table as a origin key, because employee table is one side and certificate table is many side. Here we got the output table, that is certificate table. Okay, employee ID is placed as a origin key. Then one to many relationship between employee and dependent. Here employee is there and dependent is there. Okay, one to many relationship is has dependent. Here in the dependent table, dependent name, relationship, gender. Values are Anita, Ravi, relationship spouse, father, and gender female and male. So one to many definition in the relational database is each row in the first table relates to multiple rows in the second table, and each row in the second table relates to exactly one row in the first table. So the statements are each employee has many dependent. Generating a statement from left to right, that is one to many, that is each employee has many dependent. Looking at 101 has Anita and Ravi dependents, has means multiple dependents, means each employee has a multiple dependent, and each dependent belongs to exactly one employee, that is generating a statement from right to left, many to one. Looking at Anita and Ravi, each dependent belongs to exactly one employee. That is many to one relationship is established. Output table. Output table will be, since a dependent is a weak entity, we place primary key of employee table as a origin key in dependent table to establish a one-to-many relationship. So here we are not using a separate table like we have used in the many-to-many relationship. We are using any one of these, not anyone, but only the weak entity table, that is dependent table. We are using it as a output table. Because this weak entity table the weak entity table definition is it contains the partial key, okay, which means partial key is an attribute which does not uniquely identifies each row in the table when it is alone, but when it is combined with strong entity's primary key, then both together identifies the each row in the weak entity table. And also we can generate a relationship between strong entity table and weak entity table. So in this case the employee table and dependent table. Here employee table is a strong entry table because it has primary key, means this primary key uniquely identifies each row in this table, and dependent table is a weak entity, means it has a partial key, that is dependent name, which does not uniquely identifies each row in the table alone. Okay, when it is combined with employee ID, means primary key of the employee table, means strong entity, it both together uniquely identifies these each rows in the weak entity table and establishes the relationship between these two tables. Since dependent is a weak entity, we place primary key of employee table as a origin key in dependent table. That's why we are placing a employee table's primary key in the dependent table as a origin key to establish the one-to-many relationship. Here we have placed employee ID as a origin key of the employee table in the dependent table, and it represents a origin key as well as partial key, and dependent name represents a partial key. These two combinedly represents a composite key. Both are representing the primary key of this dependent table. Okay. In this composite table, in this composite key, each attribute, means employee ID and dependent name, is a partial keys. Okay. Which means it does not uniquely identifies each row in the table alone. Okay, if we remove this, it can't uniquely identifies. If I remove this can't uniquely identifies these rows. Okay, And partial key properties, each partial key value should be related to unique primary key value. In this case, this is the dependent name, is the partial key column. So in this, Anita is related to unique employee ID, that is primary key value, and Ravi also uniquely related to exactly one employee ID, that is unique primary key 101. This is possible, but if we write Anita 101 and Anita 101, then this will not be accepted because it violates the primary key property, and hence it also prevents that each dependent from belonging to same employee twice. So that's why it reduces the data redundancy also. So all mapping cardinalities are completed in this diagram. So that's it for today's class. Hope you will understand this video, and if you feel this video is helpful, then like, subscribe, share and comment it. If you have any doubts, ask me in the comment section. I will see you in the next class. Thank you. Bye.